Moving to the next small ideas. Number of equivalents, n factor, number of moles, relations, like that. Okay. So listen. And the questions with balancing redox reaction and equivalence, number of equivalence concept may ask here in the case of titration. Okay. We have two topics in pending, that is balancing a redox reaction and titration. Redox titration. I think you are familiar it in your higher secondary on 12th. Okay. In chemistry lab, I think volumetric titrations. Yeah. So listen. Number of equivalents. Number of equivalents. NE. NE. Number of equivalents is the weight of substance divided by equivalent mass. Weight of substance which divided by equivalent mass. Ready? Let number of equivalents is equal to, what is weight? W. Equivalent mass be E. So number of equivalents is equal to W by E. Weight by equivalent mass. Similarly, one more term is the term number of moles. Let it be NM. NM. NM is the weight of substance divided by its molar mass. Weight divided by molar mass. That is said to be NM. Okay, and you know number of mole. NM is equal to weight divided by molar mass. And another term, normality. Normality N. That is a concentration term. Normality is the ratio of number of equivalents divided by volume of solution in liter. Volume of solution in liter. Like that, a term molarity, capital M, it is the number of moles. Instead of number of equivalents, here will be number of moles. Number of moles divided by volume of solution in liter. Number of moles divided by volume of solution which is in liter. Is it okay? Ready. Listen. So here normality is equal to number of equivalents divided by volume. And here molarity is equal to number of mole divided by volume. Okay. And the relation between these two with the n factor. If you want to find number of equivalents, then if you are given with the number of moles, you simply multiply it with the n factor. So number of equivalents is equal to number of mole into n factor. Here also the relation which is included with the n factor. You are asked to find normality. If you are given the molarity, you simply multiply it with the n factor. So normality is equal to molarity into n factor. Ready? Is it okay? So these are the two relations. Okay, keep it on mind. Ready? So, listen. Normality is equal to number of equivalents by volume. Molarity is equal to number of moles by volume. So, if you crossing volume to here, you obtain number of equivalents. So, This equation can be written like this. Number of equivalents is equal to normality times of volume. Like that. Molarity is equal to number of moles by volume. So if you are crossing this volume with molarity, so number of moles is equal to molarity into volume. Number of moles is equal to molarity into volume. Ready? So this much relations you have to keep in mind. Okay, this is required for the basic idea, for understanding the basic idea of your redox titration. Because in every reaction, every titration, every chemical reaction, the number of equivalents remains a constant. For every subject, for every species, their number of equivalents remains a constant if it is a balanced chemical reaction. Ready? Okay. So this is okay. So now you're okay with your equivalent mass, molar mass, and their relation with the n factor, number of equivalents, number of mole, molarity, normality. Okay. So equivalent mass is the, you know the definition, mass required to combine with the 1 gram or 35.5 gram or 8 gram of oxygen, like that. Okay. And equivalent mass you can calculate it by dividing n factor with the molar mass. And you know what is n factor now. The n factor may varies with the species. In the last section I discussed about it. Okay. So now, you have to know some more relation regarding n factor or the terms with the molar mass and equivalent mass. A term which is in connection with equivalent mass is number of equivalents. Because if you are given with a weight which upon by equivalent mass, you obtain number of equivalents. And if you are given with a weight, which upon molar mass, you obtain number of moles. So weight by equivalent mass, number of equivalents, weight by molar mass, number of moles. See the trending similarity. Like that, a term which is in relation with the equivalent mass is number of equivalents, and term which is in relation with the molar mass is number of moles. Like that. A term which is in relation with the number of equivalents is normality, and a term which is in relation with the number of moles is molarity. That is, if you have number of moles, you simply divide it with the volume, you obtain molarity. And if you have number of equivalents, you simply divide it with the volume, you obtain normality. And the normality, molarity, number of equivalents, number of moles are related like this. And this is very important. This is very important. If you want to find number of equivalents, if you are given the number of moles, simply multiply it with the n factor. Ready? That means if 2 equivalents of sulfuric acid means the n factor of sulfuric acid is 2, then it will be, if you know that 2 moles of sulfuric acid is there, then how much equivalents? If you are asked to find how much equivalents, so no need of using weight by equivalent mass or normality into volume equation. You simply use this equation. If you have moles 2 and sulfuric acid, the n factor is 2. So moles 2, sulfuric acid, the n factor 2. So 2 into 2, 4 will be the equivalents, like that. Okay. And the relation between normality and molarity. If you want to find normality, if you are given with molarity, you simply multiply the n factor of that substance, then you obtain normality. Okay. The next section, that is equivalent mass and nature of product based on medium. Equivalent mass and nature of product based on medium. So the topic is equivalent mass and nature of product based on medium. The nature of product based on medium. So equivalent mass of oxidizing agent or reducing agent is the molar mass divided by n factor. N factor means total change in oxidation state per mole. If you are given with the per mole of a particle, which means 1 mole particle is given to you. Okay, then what is the total change in oxidation state? That is the n factor. Okay, if you are given with the 1 mole of a particular substance and you are asked to find the equivalent mass of that substance, ready? So you simply find the total change in if it is an oxidizing agent or reducing agent, because we are dealing with the redox reaction, okay? It may be an oxidizing agent or reducing agent. Then what is the total change in oxidation state for 1 mole of that species? That will be the equivalent mass. Ready? And how you can find the total change in oxidation state? First of all, you find the change in oxidation state. Change in oxidation state. Then you multiply it with the number of atoms. Okay. It will be okay if you know the cases. The first one. And this is how the equivalent mass of oxidizing agent and reducing agent is calculated. And the next section, that is nature of product based on medium. And you know that each and every substance, how it can form the product, or what will be the product based on the medium, okay, which means in the acidic medium and basic medium, okay. Then only you are able to calculate the redox reaction if you are given with the statements. And the statements may be like this: permanganate ion in acidic medium reacted with the ferrous ion. Then what is the number of moles of ferrous ion required to oxidize per mole of permanganate? If you are asked questions like that, then you have to balance that reaction without any skeleton question. So question only mentioned that permanganate acidic medium with the ferrous. So you know what will be the product based on that particular medium. So that is we are discussing. In addition with that, we can also find the equivalent mass. So if you are given with potassium permanganate or simply permanganate, MnO4 minus, and MnO4 minus have 3 different properties based on the medium. And you know that even in MnO4 minus, the manganese is in +7 oxidation state, okay? And if the MnO4 minus permanganate which is exists in acidic medium, then it will turns to manganese ion, Mn2 plus. Mn2 plus. If it is in a neutral or slightly alkaline medium, neutral or slightly alkaline medium, then it may turns to Mn4 plus. Ready? If it is in a strong alkaline medium or basic medium, if they mention like that, then it will be manganate ion, MnO4 2 minus, where the oxidation state of your manganese is in +6. So first of all, you have to know, or you should know that how permanganate behaves in different manner with the based on medium. So permanganate in acidic medium forms Mn2 plus, in basic medium or in a neutral medium forms Mn4 plus, in strong alkaline medium it forms Mn6 plus. Okay, so this is the nature of product based on medium. And one more thing, equivalent mass. So what about the equivalent mass of permanganate, potassium permanganate here? And we simply take 1 mole of permanganate, 1 mole of permanganate. So this is 1 mole of permanganate. 1 mole of permanganate, so that's molar mass. It's molar mass. Let it be capital M, divided by total change in oxidation state. Total change in oxidation state means, tell me, in acidic medium, it is from +7 to +2, right? +7 to +2. So what is the total change in oxidation state? How you can find the total change in oxidation state per mole? Change in oxidation state, that is 5 units, right? From +7 to +2, what is the change in oxidation state? 5 units into number of atoms in 1 mole. In 1 mole permanganate, it is only there is only 1 manganese, right? So it will be M divided by 5. The equivalent mass will be M divided by 5. Okay. So what about here? In a neutral alkaline medium. Tell me. It's molar mass M divided by change in OS 3 unit and the number of manganese 1. So equivalent mass will be M by 3. Ready? What about the equivalent mass of permanganate in the strong alkaline medium? Tell me. Molar mass M divided by What is the change in oxidation state? Plus 7 to plus 6. 1 unit is the change in oxidation state, and number of manganese, number of such manganese is 1. So M by 1, that is M itself. So equivalent mass is M itself in the strong alkaline medium. Ready? Okay. So if you have ferrous ion and ferrous ion in basic or acidic medium, it simply turns to what? Ferric. Okay. And what about the equivalent mass? It's molar mass divided by change in OS. 1 unit is the change in OS into 1. So M by 1. Ready? If you have I minus may oxidize in acidic medium as well as in basic medium. But the types of products or the nature is entirely different. I minus in acidic medium turns to I2, whereas I minus in basic medium turns to IO3 minus. Ready? So this is the nature of product based on medium. And now we want to find equivalent mass. So here we have equivalent mass of iodide. This is a reactant and you are asked to find the equivalent mass of this one. Equivalent mass of iodide. Equivalent mass of iodide. It is equal to, equivalent mass of iodide is equal to molar mass divided by change in OS, that is minus 1 to here 0, right? Here 0, right? So minus 1 to 0. So what is the change in oxidation state? 1 unit. And number of iodine atom? Only 1. Only 1. Why? Because you are finding the equivalent mass of iodide, not iodine. Equivalent mass of the reactant. And if you have if you take 1 mole of iodide, then there are only 1 iodine atom. The product may have 1 or 2. That doesn't mind. Okay? You simply leave that concept. Okay? Or simply leave that product numbers. If your reactant, in 1 mole of your reactant have 1 iodine, then you compare it with the 1 iodine in the product also. So this is a change in oxidation state 1 and this is the number of atoms 1. So equivalent mass will be molar mass itself. M by 1 by 1. M divided by 1 in 1. That is 1. What about here? Here the iodine is in plus 5 oxidation state. So equivalent mass is equal to molar mass divided by change in oxidation state from minus 1 to plus 5. What is the change in oxidation state from minus 1 to plus 5? From minus 1 to plus 5, you know the change in oxidation state is, tell me, from minus 1 to 0, then 1 plus 1 plus 2 plus 3 plus 4 plus 5 like that. Okay, you simply subtract the greater number with the lesser number. The greater number, the higher number is plus 5 minus lesser number or lower number. Plus 5 minus 1, that is 6. So 6 unit is the change in oxidation state, right? Into number of iodine in that iodide is 1. So you simply consider, if your iodide have 1 iodine, then you simply consider 1 iodine from there. It is already 1 iodine. Okay. So equivalent mass is molar mass divided by 6. Ready? And the next idea, listen, if you have dichromate and dichromate in acidic medium, only in acidic medium. Dichromate react only in acidic medium. In acidic medium, your dichromate Cr2SN2 minus turns to Cr3 plus. And this is the nature of product based on that medium. Okay. Now I want to find equivalent mass. Equivalent mass. Listen. That is molar mass divided by, what is the change in oxidation state? Here each chromium is in plus 6 and in product it is in plus 3, right? So the change in oxidation state unit is plus 6 to plus 3. Change in oxidation state plus 6 to plus 3 into number of atoms. That is 2. Why it is 2? Because you are finding the equivalent mass of dichromate. And 1 mole of dichromate have 2 chromium atom. So since 1 mole of dichromate have 2 chromium atom, you should compare 2 chromium, or you should compare 2 chromium from here and 2 chromium from here. Ready? Which means you simply put a 2 here. Ready? Okay. So change in oxidation state plus 3 to plus 3 plus 6 to plus 3, that is 3 unit, and number of chromium atoms, that is 2, because a dichromate contains 2 chromium. Okay, here the number of iodine atom is only 1. Why? An iodide contain only 1. Ready? And if you have chromate ion, this is not dichromate, chromate ion. And chromate ion in acidic medium also turns to Cr3+. Then what is the change in case? And this is the product based on medium. What is the oxidation state of chromium here? Plus 6. What is the equivalent mass? Its molar mass divided by change in oxidation state plus 3 plus 6 to plus 3. So 3 unit, but number of chromium is 1. So m by 3 is the equivalent mass. Because in dichromate there is only 1 chromium. So you compare 1 chromium there. Or you simply take 1 chromium there. Ready? Then we have another category, hydrogen peroxide. Hydrogen peroxide. And your hydrogen peroxide, water be the medium, acidic or basic medium. If a hydrogen peroxide acts as a reducing agent, then the product will be OH. And it can act as a reducing agent in acidic and basic medium. Water be the medium, that is no problem. In both medium, it can turns to O2 and act as a reducing agent. And if your H2O act as an oxidizing agent, then the product will be H2O. And the medium will be acidic or basic, whatever it may be. Ready? Is it okay? Fine. Listen. What about the molar mass? Sorry, equivalent mass. Equivalent mass is equal to molar mass here. What is the change in oxidation state? Here -1, here 0. And 1 mole of hydrogen peroxide have 2 oxygen. So change in oxidation state -1 to 0, 1. -1 to 0, 1. Into number of oxygen atom is 2. Because 1 mole of H2O have 2 oxygen atom. So equivalent mass is m by 2. What about here? Here also equivalent mass will be m by 2. Why? Your molar mass divided by change in oxidation state from -1 to 0, right? Yes. So change in oxidation state is 1 unit. Okay. Sorry, this is not 0. This is -2. Change in oxidation state is 1 unit. And number of oxygen atoms in 1 mole of H2O2 is 2. So into 2. So this is also m by 2. Ready? Okay. We have more and more examples. That is your next one is thiosulfate. Thiosulfate S2O3 2-, and it turns to S4O6 2- in most of the reactions. Okay, then tell me, here +2, and here its sulfur is in +2.5 average oxidation state, and the actual oxidation state is discussed in the previous part. Okay, 0 +5 0 0 +5. Okay, and what is the equivalent mass? Its molar mass divided by change in oxidation state, that is 0.5 unit only, into equivalent mass of thiosulfate. You're asked to find the equivalent mass of reactant. Thiosulfate have only 2 sulfur, so into 2. So the equivalent mass is m by 1. Okay, and if you are given with the oxalate or oxalic acid, whatever it may be, oxalate, and oxalate in acidic medium oxidized to carbon dioxide. Oxalate in acidic medium oxidized to carbon dioxide. So the oxidation state of carbon turns from +3 to +4. Okay, ready? So equivalent mass is equal to molar mass divided by change in oxidation state from +3 to +4 1 unit into number of carbon in 1 mole of oxalate, that is 2. So here 2, there will be 2. So m by 2 will be the equivalent mass. Ready? And this is how equivalent mass are calculated. Is it okay? Fine. Equivalent mass based on equivalent mass of oxidizing agent or reducing agent. And this is the method to find equivalent mass of oxidizing agent or reducing agent. Okay. And these all are the products based on medium or based on their property. If it is in oxidizing agent like this, reducing agent like this, or if it is in acidic medium, it will be like this, reduced basic medium will be like this. And this is the idea based on nature of product. Now you are able to solve a redox reaction, or now you are able to, you know the basic idea, or you get the basic idea for solving or balancing a redox reaction. So I'll describe it in a detailed way. Let's check.